Joining us today. I'm Scott Loveridge. I'm Director of the North Central Regional Center for Rural Development here at Michigan State University. And we're pleased to have Steve Young from the University of Nebraska-Lincoln with us today, who together with the colleagues that are mentioned there have put together this talk on ecosystem services. So with that, I'll turn it over to Steve Young.
Okay, thanks, Scott. Again, I'd like to just give a little recognition to some folks that were helpful in um, putting together or participating in a symposium that we had at the Soil Water Conservation Society meetings in St. Louis earlier this year. Uh, Jeff Corbin, Union College, New York. Valerie Evener, University of California, Davis. Chris Dionigi, National Invasive Species Council. Craig Allen, University of Nebraska-Lincoln. And Colin Brooks, Michigan Tech Research Institute. And Lori Williams, National Invasive Species Council. So these folks were very helpful and actually participated in this symposium. And so today I'm going to talk a little bit about invasive plants and their impacts on ecosystem services. And so a little bit about what I'll be talking about in the outline that I'm going to use for this presentation. I'll be discussing invasive plant species impacts, talking about ecosystem services, defining those, and also presenting information on kind of two approaches: the theoretical framework for assessing invasive plants and ecosystem services, and the practical considerations for reducing invasive plant species impacts on ecosystem services. And finally, do a summary at the end. Hopefully we'll have time along the way. Be willing to answer questions or address comments as time allows. So that invasive plant species. We know or are aware of invasive plants. They're increasing importance in many ecosystems. As you can see from this picture, several different locations or regions, arid regions, wetlands, forest, shrublands, riparian areas are not immune from invasive plants. So as these plants invade and infest these areas, they're making contributions to ecosystem services. And they're present in nearly every region and most habitats. In this picture or this chart that I'm showing, different regions in fact have invasive plants, which we all know of, or most of us probably are aware of. Um, and then looking at on the biome scale, we can see even at these different biome levels we have invasive plants. And so a lot of exotic invasive plants that are occurring throughout regions and biomes. But with that, their presence, they also have an economic impact. And a recent study or more recent study has shown that in the U.S. this is in the $120 billion a year range. So an economic or monetary value is now assigned or associated with these invasive plants. And a chart here to show the increasing frequency of invasions. This is from the Millennium Ecosystem Assessment, starting with early in the 1700s all the way up to late 1900s. We can see this trend of increasing invasive plants, particularly in case in marine coastal situations. So defining ecosystem services. First of all, I just want to show this picture of ecosystems which have obviously been affected in one way or another. We often take these ecosystems for granted, but they do or can be overwhelmed, whether it's air pollution, whether it's a water event, desertification, things like that do affect ecosystems. We look at something that's not as obvious or more subtle, in particular invasive plants, we can see that they're having an effect too. This slide here shows, for those of you in the arid west, particularly medusa head, that's establishing in some rangeland situations, and very detrimental to forage production and biodiversity of those systems. So not as obvious as those earlier pictures I showed, not as graphic, but yet still detrimental and potentially harmful. So if we talk about ecosystem services, about 5 years ago now, the Millennial Ecosystem Assessment was done, and several categories were identified that relate to the services that ecosystems provide. And I'm going to show these as I move through here, talk about each one a little bit. Provisioning. These services are typically those that provide the food we eat, fresh water, pharmaceutical services, energy, fiber sources, so things like that. Regulation. These services typically deal with cycling of nutrients, carbon sequestration, and also other things that occur, flood control, pest control. And we also have cultural services, the things that we kind of take for aesthetics, whether we enjoy those or whether we use those for recreational purposes, spiritual heritage type things. Those provide a service that is somewhat tangible yet still important. Supporting services, I mentioned that cycling was in regulation. I misspoke there. It's actually in the supporting category as far as nutrient cycling and other cycles, carbon, nitrogen, as well as seed dispersal, and then you have things like primary productivity associated with plants and that sort. So those are some of the ecosystem services. If you overlay on that or include in that biodiversity, see that this kind of adds another layer, especially when we're talking about plants, because invasive plants are very exclusive in how they establish and create monocultures and have a big impact on biodiversity. So this is a category that is not included in a separate category, but is important nonetheless in our evaluations of ecosystem services. So many of these categories are impacted and declining under current scenarios. Look at the impact of different activities and different things that are occurring, different scales. We can see that these services are actually fluctuating. They're not static. They are in fact dynamic, and so we see constant changes. And with those constant changes, invasive plants are part of those areas that are receiving some are being changed. So I'm going to now progress to the some of the things are the kind of the main part of this presentation, and talk about theoretical framework for assessing invasive plant species and ecosystem services. And this is, a lot of this information comes from the symposium, so been taking some of this from the presenters there. And first of all, one question is, how do we assess ecosystem services? Indicators must be, first of all, representative, they must be reliable, and they must be feasible. So to meet these categories, we have to account for different factors, and some of the current assessments that are that have been done. If we look at a quote from this is a paper by Bennett, it says, because ecosystem services can be difficult to measure directly, scientists have tended to use land use, land cover as a proxy for the provision of services, even though the relationships between land use, land cover, and service provision are largely untested for most services in most regions of the world. So we know that services are there, but as far as assessing them, there's some challenges, and those challenges are daunting in some aspects, yet attempts are being made. So what is it that we need to understand to manage ecosystem services? We know a lot of these things for ecosystem functions, but can we use that? So for example, who are the key ecosystem service providers? What are the components of community structure that influence function at landscape level? What are these, what are the mechanisms that are associated with that? What are the key environmental factors? Not only biotic, but also abiotic. How are those influencing? And also, what are the spatial temporal scales over which providers and services operate? So in space and time, how do these services and the of them affect each other? In this figure, this is an example of invasion by exotic woody species into South African and the idea is to show that with different infestation levels, there's a change in the percent of precipitation available. And one of the biggest effects on this is year-round water use. So if we take this example and talk about exotic species, the reduction or the effect on cover also has an effect on water yield. And an area that's being looked at or considered in South Africa, and there's also application or consideration of this in other locations. If we move to a more ArcGIS type mapping situation, looking at where different services in this case, or environmental factors or conditions exist across the landscape. We can see that water quantity, forage production, carbon storage, flood control really varies across landscapes, and often these estimates are based on a coarse scale rather than a fine scale. So it gives us an idea, but getting at more detail is often needed in some of these situations. Try and speak up. I know there's been some comments on that. Let me know if I'm not speaking up enough. In this graphic, we can see particularly the effect of ecosystem processes impacting water supply. Um, so if we look at fog and cloud interception, surface runoff, infiltration, canopy interception, and evaporation, and then we get down here to plant water use, we can see that in addition to plants using water, there's also other factors that are occurring, and so those are an important aspect to consider the whole system, not just one part of it, but the whole ecosystem and how it's functioning. And also to identify those processes that are potentially available for using as proxies to assess potential impacts. If we look at, in this case, individual trees versus trees on a stand scale, we can see their impacts on, in this case, water savings. On the individual tree scale, the effect of a tree using water is pretty significant. But then at the stand scale, the difference in water consumption between a woodland and a grassland is, in this case, estimated at 40 millimeters per year. So spatial scale is important to consider when talking about these impacts and ecosystem services. How are ecosystem services different from functions? This is an important concept because services are integrated across multiple ecosystem function and attributes, and there's an emphasis on scale and location, and on multiple services and trade-offs is different compared to functions, and there's a distribution of services depends on the distribution of functions as well as human demands. So if humans have a higher demand in certain areas, this is going to affect services in those areas, and maybe not as much on the function of those ecosystems. So a little bit of a difference there, but still important to consider as we try and assess these services and assess impacts from invasive plants. So we know invasive plants can impact ecosystem services. I've stated that already. But assessing and predicting these impacts are a challenge. So the question is, can we use the functions of ecosystems as proxies for services? We're very familiar with functions. Can they be related to services? If we look at another question is, how strong are broad generalizations about ecosystem impacts of invaders? Are these broad generalizations adequately are they suitable for assessment? And then look at going beyond and looking at some more finer detail, context, dependence, abundance, community interactions, temporal, spatial scales, and then how do we integrate all these factors? So that's a challenge right now. I see there's a poll up. Scott, would you like me to take a break or continue on?
We can put the polls up whenever you want to get them in there.
Okay.
Do you want to ask your first poll at this
Sure,
point,
why
or?
not? Let's go ahead and do that. First question is, are you managing public or private land? And go ahead and answer, and we'll see kind of the dynamics of the group that's I have to open that?
Let's see. Is it,
Okay.
there we go. Now it's working. So it looks like most people are doing both public and private, and just a few that are just backyard
Okay, well,
managers.
that's good. So there's a range of people listening, and obviously it's an issue that spans public and private land. I'm going to go ahead and close that poll and continue on here. So if we get back to the idea of using ecosystem functions as proxy for services, um, we already have a strong understanding of many species effects on ecosystem functions. Ecosystem functions can be used as proxies for services, but we need to consider how services integrate these component functions over space and time. Um, and even with these considerations, the predictions based on functions are likely to be an improvement over current assessment techniques. So um, it is possible, and I think that is a direction that we're going, and it's one of the better assessment tools that we have. So if we talk about invaders' impacts on services, this diagram shows mechanisms of ecosystem service alteration by invasive species. So in this diagram, we can see that basically the spread of invasive species is a direct relationship to some of the mechanisms involved, as you can see on the arrows going up. And if we consider all these mechanisms, it becomes a challenge. But it's important because each mechanism is affecting invasive plants and their effect on services. So this is an attempt, a way to do that. Um, if we look at some of the current broad generalizations about ecosystem impacts of invaders, um, it might be where we move from a quote all invaders category to more of a functional type generalization. And when we talk about functional types, those can be referred to as, in some situations, nitrogen fixers, um, woody invasion into grasslands. Uh, in this case, um, these types decrease water provision, increase carbon sequestration, and then we have high biomass producers that tend to be present near waterways. So um, invaders that provide novel functional types are maybe a different or a new way to categorize invasive plants. And some examples of that are, in this case, the effect of woody invasion into grasslands. We can see that as the proportion of change in soil carbon as grasslands change to shrublands, we can see that there's a resulting increase or decrease in carbon based on this change in plant type and plant community. Um, Talking about the less obvious changes, as I showed this earlier, I talked about vegetation types that are not real easy to see differences in the field, and so this is another consideration. When there's when the vegetation is not real clear as far as the differences. Uh, in the case of water use, by in general vegetation, we see differences if we look at this table showing some of the common vegetation that's associated with more of the riparian areas. The consumptive use of water it ranges pretty widely on this scale. And this table shows a summary of some of the work that's being done, but the consideration is that variation within these plant types is sometimes very specific. Another example of that, this is some work that's actually being done in Nebraska, looking at seasonal ET, in this case of Russian olive, a very prominent non-desirable. It's a plant that occurs in riparian areas, but we can see that quite a range of ET values, and depending on season. But if we look at the seasonal low, 11.8 inches of water, or 10.5 gallons of water per plant per day, versus a high of almost 37 gallons of water per plant per day. So variation in plant type and location. If we look at salt cedar, tamarisk, again, a similar situation in the amount of water that's being used on a per plant per day. So, um,
Steve, could you define ET? There's a question about that.
oh, ET, that's the evapotranspiration. So that's the water that moves through the plant system, the amount of water that the plant transpires given basis. It doesn't always have to be plants. ET could be from soil surface, from you know, wherever water is stored, the amount of ET that's being released. Um, so how
And there's
strong?
another question about how it compares with natives. How do you know whether it's high or low compared with the natives?
That's a good question. And the term high or low, as I see it's in quotation, is a relative term. So um, you know, comparing to natives, there's actually been work that shows that the natives that ET that respire equal amounts. But it also gets back to the per plant aspect, and also looking at the plant type, um, and variability across a range of locations and situations. And that's a challenging aspect to measure, and a lot of models are being developed for that, and a lot of field work, field studies are being conducted to try and get at that. If we talk about, again, broad generalizations, um, they're a good first step. I think it's important that we make that first step, but we need to continue to refine those generalizations and get more specific. Um, Management and updated theory should be based on measurements of individual invaders across space and time. And if we put these together, I think we start to build a better predictive framework. And we need to have a better ability to predict impacts within broad groups of plants with multiple traits that are very strong predictors. So I'm going to talk about some of the more specific examples of moving beyond generalizations. Um, if we look at the the context dependence, in this case environment, different traits regulate functions in different environments. A given species alters its traits in response to its environment. In these cases, plant genetics is an important component, and not necessarily changing in those genetics, but just the genetic makeup of the plant that allows it to establish or exist in an environment that, in invasive plants case, it didn't have in its native range. Ecosystem effects in terms of abundance and community interactions vary with abundance. Is this linear, non-linear? And the impact of abundance depends on similarity in function. How do these plants function? We talked about moving from all invaders to functional groups. So the question is, in this case, what density does a plant need to be at to have an ecosystem effect? In this case, looking at a forest system with fir and alder, on the mass loss, there appears to be an effect if we move to 100% alder. But if we go from mineral nitrogen, in fir, 100% fir, the situation is different than 100% alder. So these are based on 100%, but how does that change if we look at less than 100%?
Sharon wanted a definition of mass loss.
That is, I'm not totally sure what that is. I think it refers to the amount of mass that the plant loses over time based on, well, in this case, foliage litter. I don't know, to be honest, so I can't answer.
Well, the legend under Figure 1 says that it is in fact stuff that drops off of the trees, basically.
Yeah. If we look at, in this case, non-natives' impacts on soils, even at pretty small populations, we can see there's an effect, particularly microbial activity. In this case, this study was looking at the impacts of invasive plants on soil carbon and microbial activity, and when there was invaders present, there was more activity in microbial populations than when the invaders were removed. Now, was that activity beneficial? Was it directly induced or as a result of the invaders? That's hard to say, but there's an effect that's occurring, and the main point is that even in small populations, this effect, especially on soil and soil microbial components, having an effect. So finally, the spatial temporal scale. Talk about the heterogeneity within vegetation types and across landscapes. The scales are changing, and scales at which services and functions are regulated and needed for human use are correlated. So a couple of examples there, and this is from the Millennium Ecosystem Assessment again. If we look at variability, annual and seasonal, an example is cheatgrass net primary productivity. Varies tenfold year to year, but if we look at the figure, we can see that the first perturbation, second perturbation, or disturbance, there's different reactions that occur during these different times. So these quote-unquote hot moments, how long do they last? What is their scale at which they last? The thresholds. What is the threshold for in this case, the first state or the second state, and how important is that? And the directional shifts over time, and how are those fluctuating with these at these different scales. If we look at the different patches of landscapes that provide different services, spatially, there's quite a bit of variation. In this little figure, looking at the region of ecosystem assessment, where you have kind of the interface of urban, irrigated agriculture, natural forest, coastal aquaculture, wetland. Um, if that was a scenario that occurred, you can see the different services in these different locations on different scales. So the invasions of non-native plants alter services by making the landscape more homogeneous, and therefore affecting these services and causing or making it very important to consider the location of an invasion across the landscape. And then I guess just to kind of summarize or finish this section a little bit is obviously the assessment and prediction of ecosystem services impacted by invasive plants obviously requires integration across complexity. As I mentioned, invaders have an effect on ecosystem functions, and these changes occur within different environments at different abundances. They impact community interactions, and they occur over space and time. So the current trait-based predictive frameworks can be expanded and coupled with landscape theory used to predict some of these variations. Now, obviously, it's easy to say these kinds of things, but the practical aspect is another part. So this is the theoretical components, and the next part of the talk is going to talk a little bit about practical considerations. So I guess we could stop and have another question if that's appropriate, Scott. Okay. Are invasive species an important problem in your area? That looks about right. I wouldn't think we would have number 4 checked off because most people are probably interested in that, so that's why you've tuned in. So obviously very important. I think there's a, can we do the next question too while we're at it? How much do invasive species hurt your local economy? So because you've got invasive plants, what are the impacts on the local economy, local situation that you deal with? Okay, we've got a few economists out there. Um, People don't know, and that's I think that kind of tells the story of where we are as far as in terms of ecosystem services, and as far as putting some value on things. So if we could go back to the presentation. The next part of my talk is going to be on looking at practical considerations for reducing invasive plant species impacts on ecosystem services. So if we talk about the practicality of invasive plant species and ecosystem services. So obviously invasive species have affected ecosystem services, but a big question is, can we restore ecosystem services following invasion? So if we have our assessment and prediction addressed, theoretically, what kinds of things can we do in a practical manner that would kind of help give us a more applied approach or a more applied aspect? So we've shown that not all exotic species are equal, so there's a need to prioritize. Often management decisions are based on priorities and goals that are set forth before management has implemented. Species impacts are driven by species traits, habitat characteristics, as we've discussed previously, and removal is not often enough. And this is an important concept because, as one of my colleagues that was part of the symposium has indicated, legacies are an important part that needs to be considered. So invasive species and biodiversity. This chart shows the percent, if we look at the far right column, the percent plants that are causing a decline of threatened and endangered species in the U.S. Alien species make up 57% of that. And so, an indication that invasive species are impacting biodiversity and causing significant community changes. We look across landscapes and we see, in some cases, vast monocultures of invasive plants. And those landscapes have changed from previously native or a mix of native desirable plant types. If we look at some of the work that's been done in this area, almost 50% of listed species in the U.S. are affected by invasive species, and multiple factors, including land use, invasive species, not always can be separated. But some studies have shown that species invasions may increase biodiversity, not the way we would maybe necessarily prefer. But in summary, the role of invasive species in extinctions of plants might be overstated. There's some work that's showing that is possible. But definitely significant shifts are occurring in community composition. So we can see these changes occurring. If we talk about the supporting services, they provide indirect benefits to humans through other services. Invasive species often, but not always, increase net primary productivity and net nitrogen cycling rates. Invasive plant species have increased some measures, but this is not necessarily beneficial. And I'm going to give an example of that here in a couple of slides. Well, the next slide, talking about provisioning services. In this example, water hyacinth in Lake Victoria, Kenya. In 1998, there was greater than 20,000 hectares. In 2005, it was nearly absent. In 2006, a reinvasion following heavy rains and nutrient influx resulted in these dead zones or loss of fishing productivity. So in this case, the effect of water hyacinth has been substantial in increasing the nutrient load in this system.
There's a question from Melissa. She wants to know if there are models that are effective in prioritizing invasive control.
To my knowledge, I'm not aware of any. Not that there aren't any. I have not run across those. I'm sure there's others in the group that probably are more familiar with those than I am at this point. Definitely something that would be useful to work on.
Yeah, this could be a case where we could use the cloud. If someone's aware of some resources in that area, you could just paste in the URL for that into the chat, and then you can do that after the presentation's over.
Sure. Yeah, and that goes for any of these points. If some of you folks have some resources or ideas or areas that you could contribute, that'd be more than so provisioning services, again, we know this is an important part of what we depend on as far as food, water, um, but we see invasive plants affecting these areas, very commonly seen in agricultural productivity, but also in some of the less intensively managed areas, pasture land, um, and the well-established negative impacts of invasive plant species on provisioning of services has been documented. So pretty significant amount of work there. Regulating services, carbon sequestration. This is an area that invasive plants are affecting as well. If we look at this chart, we can see the contribution by invasive plants and their invasion on ecosystems and their contribution to carbon pools as these communities change from natives to exotic. Another example is tamarisk, particularly in the southwest. As most of you are probably familiar with, tamarisk is a shrub or small tree from Eurasia. It often primarily invades riparian habitat, widespread in the arid, semi-arid regions of North America, and typical of invasive plant, it displaces native vegetation. Studies have shown that it increases fire frequency, water transpiration. As I mentioned previously, there's more than one study looking at transpiration of water from salt cedar, and it also affects flooding and erosion rates. So there's a number of examples for plants in this area, but probably better documentation exists for all invasive species, not just invasive plants. Aesthetics. If we consider aesthetics, I mentioned it earlier, the categories for what is an aesthetic ecosystem service. Lupins, in this case in California, are native. Purple loosestrife in Connecticut is exotic. They're both beautiful. They're both very pleasant to the eye, yet they both have some significant impacts. Well, the invasive has significant impacts beyond just its beauty. So
There's a question.
Nevertheless,
there's a question from Michael Byer about weed productivity. I think it maybe relates to us a couple slides ago.
Oh, okay. The 12%. I think what is there is they're actually referring to invasive plants affecting agricultural production. I don't think it was agronomic weeds in general. I could be wrong about that, but I think it was invasive plants. So that's why the number was so low. So cultural services, this is probably one of the most difficult to quantify or generalize, but obviously there's interest. Local, state, national policy initiatives indicate that invasive species threaten things that are widely accepted as important. Things like boating, hiking, fishing, bird watching, things that we consider important to our livelihood is something that is included or should be included in these evaluations. So the practicality of invasive plant species and ecosystem services. We go to so obviously they've affected ecosystem services. In some cases more significant than others. But the question is, can we restore ecosystem function? And following an invasion. Many of us are familiar with the control of invasive plants, removing them from locations. There's manual, chemical, biological methods available, but in many cases removal alone is not enough. because legacies, the lasting effects of invasive plants exist. Uh, Legacies such as changes in soil structure, changes in contribution of propagules to the soil seed bank, um, the effect of a monoculture of invasive plants, eliminating or reducing a native plant is a legacy that is that occurs, and it establishes during an invasive plant species occupancy, kind of like moving into an apartment. And if you respect an apartment and cause damage, you don't have a legacy on it. A legacy that is long lasting is felt long after the plants have vacated or been removed. So if there's been a lot of damage, the legacy is more significant and more felt by the environment or the community that existed. So talking about some of these things, changes in nutrient pools, nitrogen cycle is one that invasive plants affect. Um, the difference between pools and fluxes is an interesting topic. Plants change fluxes, and they also contribute to the pools. In this case, minerals, soil organic matter, and then the different things that occur following the result of those pools, whether it's mineralization, nitrification, or leaching. So these effects are dependent on the plant and the legacy it leaves. Nitrogen fixers increase soil nitrogen pools. In some California situations, non-native grasses increase nitrogen leaching losses. And then, as we've already talked about, Tamaris affects sedimentation and stream channels. So changes in soil biota. Talking about, again, microorganisms. If we look at the soil, in this case, soil from garlic mustard stands has lower mycorrhizal fungi colonization. Soil from garlic mustard stands has lower tree seedling growth. So the mechanism is that garlic mustard disrupts plant fungal mutualism, and I know this is really being focused on in a lot of studies because soil is a major component of how invasive plants establish not only the biological conditions of the soil, but also the ability of the soil to hold moisture and the penetration of invasive plant roots. So as I've indicated, legacies of invasive plant species. If we're going to approach restoration to have success, we need to consider such legacies and their costs to the ecosystem, whether that's economics, whether that's environmental, but the long-term aspect of the legacies of invasive plants. So the practicality of invasive plant species and ecosystem services. Can we restore ecosystem services following invasion? Yes, but more than just removing the target species is needed. And a lot of this is important for long-term control or maintenance of areas where invasive plants have been removed, because removing one plant often will result in the recolonization of another plant. So more than just removing plants, but considering the long-term effect is important for restoring, in this case, ecosystem services following invasion. So in summary, the current and future directions in this area I think we need to continue to fill the knowledge gaps on the processes underlying ecosystem services and impacts by invasive plant species, whether that's theoretical or practical. There's still a lot of information that's needed to fully assess this. Also evaluate the benefits of ecosystem services and the trade-offs among management actions related to invasive plant species and that affect these services. So what are the benefits and how do management decisions affect those? Similarly, determine the value of ecosystem services to more accurately direct the decision-making process. If we know the value of a service, will that how much will that impact our decision-making in managing invasive plant species? And finally, incorporate technology to identify and quantify ecosystem services at the landscape scale. I think there's a lot of tools out there that are available. Some of our mapping tools, mapping technology can be broadened to look at ecosystem services in addition to invasive plants. So those are some of the things I see as the current and future directions. Obviously, the list could be expanded. But with that, I would like to end. And first of all, I'd like to acknowledge the North Central Regional Center for Rural Development for providing funding for the symposium that was held at the Soil Water Conservation Society annual meetings this last summer, and also for the Soil Water Conservation Society for hosting the symposium that we had. So that's all I have, Scott. I don't know if we have time.
Okay, yeah, there's some questions coming in.
Answering questions.
Also, I'd like to just open up a kind of a summary evaluation poll here to let people kind of give us some feedback on the webinar overall. Let's see if we can get that up and running here. Okay, and this is one where you click everything that applies. So you have options of clicking more than one thing, and then maybe in the meantime, as folks are answering that, Steve, if you could answer Brent Rogers' questions about, if you remove the invasives, will the system self-restore, or does it take a more deliberative action to get the system back to the pre-invasion status?
Yeah, that's a good question. I think a lot of times it's kind of established native plants, following some cultural activities to remove invasives, and pretty confident that without taking some kind of measure, the native or desirable plants were not going to just come. In some situations, those plants that we want just all of a sudden come back. They need some assistance, some management. That would be my answer for that.
Okay, well, I think that's looks like okay. Laura has a couple people also contributed some ideas on that. I think Debbie Morton and Laura and also Marilyn all presented some things, and Beth has got something as well. And you can, if you're a part of Extension and you want to document that you've been part of that, you can go in and log in and do that there. So great. Thanks very much. I enjoyed the webinar. I've been involved with some of these things around the edges, working with the Michigan Natural Features Inventory, but it was good to get a good overview of this.
Yeah, and just to follow up, we are planning so for those of you
Very good. And it looks like there's some good dialogue here. I think we're going to close the webinar, but if people want to continue on in the chat, yeah, and one just got a question here. How to access this webinar if you want to play it back later. Just go to our main web page, which is http://ncrcrd.org, and then click on webinars, and that will get you to a list of upcoming webinars as well as archived webinars, and this will be among them. And that URL should be posted within the next 24 hours or so. So you'll be able to access it very soon. So thanks for that question. Yeah.
And my email address is probably posted there as well.
I think so. Okay, well, I'm going to get off now, and I think, Laura, you can turn off the recording.